All right, so I want to take some time to introduce you to the POW function. This is a function I've seen on other videos that I think really helps when we're working with these exponentials. So first of all, what does it do? We've got this equation, 3 to the power of x is 81. Now, looking at that, hopefully we can see that x is 4. But I want to write this in another way. 3 to the power of x is 81. Well, what is this saying? This is really saying, what power of 3 is 81? And the answer, as we already said, is 4, because 3 to the power of 4 is 81. So here, 2 to the power of x is 8, so we could write that as, what power of 2 is 8? And of course the answer to that is 3, because 2 cubed is 8. What power of 4 is 2? Well, 4 to the power of 1/2 is 2. So that answer is 1/2. Because, as I just said, because 4 to the 1/2 equals 2. Finally, what power of 5 is 1/25? Well, we've got to send the 5 to the bottom and square it, so the answer is -2, because 5 to the -2 is 1/25. So we have this notation. What power of 5 is 1/25? Which is just another way to write it. I'm not sure that it's really any simpler than this for these types of problems. It gets its value when we get to more complicated things. When we were playing with Sierpinski's triangle and the candy corns, candy corn kernels, anyway, we had 3 to the power of x is 10,000, and we wanted to know, when is this true? And so again, we can write it as POW base 3 of 10,000, but how is that any better? Because we've still got to know what power of 3 is 10,000. And we did it with some trial and error in class and found that this is somewhere between 3 to the power of 8. 3 to the 8 is less than x, which is less than 3 to the 9. So we know that this answer is between 8 and 9. Is there a way to get it exactly without just doing trial and error? And, well, here's what we're going to do. First of all, I like this POW notation because it makes it really clear we're doing powers. But if we look at our calculators, there's nowhere on this calculator that we can do a POW function. We've got the x to the power of y. If we know the x and y, we can get the answer, but we know the x and the answer, we need the y. Well, calculator does have this log function. What does that log function do? Well, first let's look at it here. The log function, what we would write is we would write log base 3 of 10,000s. And this actually means exactly the same as this POW function. Really, POW and log, they're replaced with each other. I use POW to start off with because it makes more sense. Why do we use log? Well, maybe log is the Latin word for power. No, it's not that. I'm not really sure exactly why it got the name log originally, but that's what stuck. So we can calculate this POW function using the log function on our calculator. But how does it work? If we try doing log of log 3 10,000, well, it just starts putting it all together. The problem is this. The log can have any base we want. We have a base of 3 here. On the calculator, that log is always, the base is 10. The log base 10 of 100 is 2, because 10 squared is 100. So the only one the calculator can do is log base 10. So what we've got to do is we've got to figure out a way that we can put log base 3 into the calculator. So let's look at this one first. Log base a of b equals x. How can we write this in a way that we can calculate it? Well, first of all, log base a of b is x. That's the same as saying a to what power is equal to b. What power of a is b? So a to the power of x equals b. These two statements are equivalent. Now I'm going to go ahead and take the log base 10 of both sides. And so I'm going to call this log of a to the x. When we do base 10, we don't write the 10 there. It's understood, kind of like square root, the 2 is understood. So log of a to the x is equal to log of b. Now, how can we simplify this? Because again, our goal is to figure out what is x equal to. Let's look at it a slightly different way. I'm going to ignore the log b for right now, and I'm just going to say, okay, log base a of x, log of a to the x is equal to something. So let's just take a side note for a second and say log a to the x is equal to something c. And I'm going to even say that log of a is equal to d. And I want to see, is there a way to relate log of a is d to log a to the x is c? Well, if log of a is d, then that means that 10 to the power of d is equal to a, right? Well, what if we raise both of these to the power of x? If we raise both of these to the power of x, we get 10 to the d to the x is equal to a to the x. Well, 10 to the d to the x is the same as 10 to the power of dx is a to the x. So what are we saying here? This original question said, what 10 to what power is a to the x? Well, 10 to the power of c. This right here says that 10 to the power of c is a to the power of x. But we just said 10 to the power of dx is a to the power of x. So we know that c is equal to dx. Interesting. So if we take this one step further, we can see, okay, c is log of a. I'm sorry, c is log of a to the x. d is log of a. So from that, we can see that log of a to the x is equal to, I'm going to swap the order here, x times log of a. Okay, let's look at that again real quick. Log of a to the x is c, means that 10 to the power of c is a to the x. Log of a is equal to d means that 10 to the power of d is a. But if we raise both sides of this equation to the power of x, we get 10 to the dx equals a to the x, which means from between this and this, we know that c is equal to dx. Going back, c was log of a to the x, d was log of a, so log of a to the x is equal to x log a. And this is true for anything. That's why I used a, b, that's why I used letters, to show this is true of everything. So when we have here log of a to the x equals log of b, we can go back to this and say then that x log a equals log b. And I didn't really leave myself much room, so what does that mean? Well, that means that x equals log A divided by log A. It actually means log B. X is log B divided by log A. And this log can have any base, but in this case, we want it to have a base that our calculator can calculate. So let's go back up to here. Our original problem was log base 3 of 10,000 is, using that rule we just wrote, it's log base A of B is log of B over log of A. So this is equal to log of 10,000 divided by log of 3. So let's go to our calculator and check that out. What is log of 10,000 divided by log of 3? The answer is 8.383613097116, and the decimal would keep going, but that's good enough for us. And so this is approximately 8.38. And that's what we found. Our problem said, hey, it's going to be between 8 and 9. 8.38 is between 8 and 9. We've solved this answer. What power of 3 is 10,000? Well, 3 to the 8.38 is 10,000. And let's double check that. If we do 3 to the power of, and notice the answer is that thing, so I can just say 3 to the power of our answer, we get 10,000. Cool. So we can now work these powers out. I'm going to scroll past this problem a little bit and write our rule down again. Our rule simply says that if we're trying to do a problem like 2 to the power of x equals 75, well, we can write that as what power of 2 is 75? And our calculator doesn't have this power, so we actually write that as log base 2 of 75 is what? And so we use our change of base formula, and the change of base formula says that is equivalent to log of 75 divided by log of 2. And so log of 75 divided by log of 2 is 6.2288. Now, obviously, if you're doing this problem, you would probably just say, hey, I go straight from here. Depends on how you do this. You might go straight from here to pow base 2 of 75 and then convert that to logs when you're dividing, however you want to do it. But the key is that log base A of B is equal to log of B divided by log of A.